The Atacama Desert in northern Chile. This desert, with its high mountains, plateau and active volcanoes, is probably the driest place on Earth. This inhospitable terrain is where ESO, together with international partners, is building the world's largest astronomical project. The first of 66 state-of-the-art antennas has just been handed over to the project. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the far reaches of the universe with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESOcast. In today's episode, we're going to travel to the site of ALMA, the Atacama Large Millimeter and Submillimeter Array. This amazing new telescope is being built right now in the Chilean Andes at an altitude of 5,000 meters, high enough to be literally breathtaking.
ALMA will initially comprise 66 high-precision antennas with the option to expand in the future. There will be an array of 50 12-meter antennas acting together as a single giant telescope, and a compact array composed of 7-meter and 12-meter diameter antennas. The first 12-meter diameter antenna, built by Mitsubishi Electric Corporation for the National Astronomical Observatory of Japan, one of the ALMA partners, has just been handed over to the observatory. It will shortly be joined by North American and European antennas.
Each new antenna must meet very strict requirements. The surface of each dish must be accurate to the thickness of a human hair, and the pointing must be precise enough to pick out a golf ball at a distance of 15 kilometers. This antenna handover is a major milestone. The observatory team can now proceed to integrate the rest of the components, including the sensitive receivers that will collect the faint signals from space.
The antennas are tested at the Operations Support Facility at an altitude of 2,900 meters, before being moved to the plateau of Chajnantor at 5,000 meters. The Operations Support Facility will also be the center of the observatory's scientific activities.
The ALMA site was chosen because its extreme dryness and altitude offer excellent conditions for observing the submillimeter radio waves for which ALMA was designed. What's more, the wide plateau at Chajnantor offers plenty of space for the array of antennas. The individual dishes will be spread out and linked together over distances of more than 16 kilometers.
The ALMA antennas must withstand the harsh conditions at Chajnantor, with strong winds, cold temperatures and a thin atmosphere with half as much oxygen as at sea level. This forbidding environment also poses challenges for the workers building ALMA.
Although each of the antennas weighs about 100 tons, they can be moved individually to different positions in order to reconfigure the ALMA telescope. Now this will be carried out by two custom-designed transporters. Each of these giant vehicles is 10 meters wide, 20 meters long and has 28 wheels. Now that's what I call a monster truck. With ALMA, astronomers will observe the cool universe, the molecular gas and the tiny dust grains that constitute the building blocks of planetary systems, stars, galaxies and even of life itself. ALMA will provide us with new and much needed insight into the formation of stars and planets, and it will reveal distant galaxies in the early universe, which we see as they were over 10 billion years ago. I'm Dr. J, signing off for the ESOcast. Join me again next time for another adventure in the far reaches of the universe. And now I really need some oxygen.